We are the Check Engine team. This presentation has been prepared by David Lamar, Tanner Gibson, and James Cory. Over the past few months, we've been designing a mobile application that allows users to diagnose their vehicle when they're having problems with it. We've noticed that there aren't many apps out there that allow people to diagnose their vehicle or help in any way if they encounter car troubles. We thought it would be a fun project to look at how an app like this would behave, since there aren't a lot of them to base design decisions off of. Throughout the course of this project, we've done several tasks to help guide the design of our application. We've conducted a survey to understand what our user base would be looking for in an app like this. We've created personas and user stories so that we can better understand our user base. And we've done several rounds of user testing with low and high fidelity prototypes so that our design accurately reflects what users want and makes our application easier to use. Through all of this, we've come up with a final high fidelity prototype that emulates what a finished application would look like. I will run through a quick demo of our application and the features that it offers. This is the login page of our application. Here, users can type in their account details to access their saved information. If a user doesn't have an account, they can click on the Sign Up button, which I will do now, and create an account. This page just asks for some general information so that a user can be recognized by the app. I'll enter a username, a password, and an email and create our demo user. Now that our account has been created, we can see the home page of Check Engine. We have options to diagnose your vehicle, see its information and maintenance logs, as well as an option to add another vehicle to Check Engine to keep track of. I'll navigate to the Diagnose page and we can see the main idea behind this application. So, with how technology is progressing these days, we thought that it would be cool if an app could simply diagnose car problems from recording audio. This technology is pretty experimental, but we're seeing similar applications being used today with voice recognition. The idea here is that you can click the Record Noise button and Check Engine will listen to your car. You can also optionally enter an error code if you've gone to a mechanic or an auto parts store and diagnose issues with a more powerful tool. If we then click the Diagnose button, we will be shown potential causes of our car troubles. In this case, we've gotten a muffler leak and a tailpipe leak. Check Engine gives a quick cost estimate, and if we expand the item we're interested in, say the muffler leak, it will give us the description of what a muffler leak is and what needs to be fixed. Now that we've diagnosed our vehicle, maybe we want to actually get it looked at by a mechanic or do some work on it ourselves. We can go to the vehicle information page and get a better idea of what has been done to our vehicle and the make and model of it so that we can order the right parts we need. We can see we've got a 2001 Oldsmobile Aurora here with 100,000 miles. We can see that our last maintenance on our vehicle is on May 16th of 2017. Let's say that we've just gotten our headlights replaced and we wanted to document this. We can add a new entry in the maintenance log with this Add button. I'll put some information about what we did, like the date, the cost, and the description of what was done to the car. And after submitting that, we can see that our maintenance log has now been updated with the correct information. Heading back to the home screen now, what if we don't want to work with the Oldsmobile Aurora? Maybe we just got a new Honda Civic or something, and we want to log some information about that instead. Up next to our selected vehicle, we have an Add button. Clicking on that, we're brought to an interesting screen. This was another big idea we had for this application. We thought it would be cool if you could just take a picture of your car and Check Engine would automatically get its make, model, year, and color for you. So, since this is a prototype, you can imagine that we're taking a picture of a Honda Civic here. After taking our picture, we're redirected to a screen where we can verify the results. It all looks good, but we'll add in the miles of the car since the image couldn't get that. Now our car has been added and we can diagnose and add maintenance information as our heart sees fit. Those are the primary features we've designed for Check Engine. Now James will go over the results of our evaluation sessions.
We wanted to get a feel for how easily users could use our application. We took some of the main tasks a user may use in our app and created goals for how quickly users could complete the tasks and how many errors they'd make along the way. We also requested that users fill out a survey when they finish testing to gauge their overall impression of our app. Some of the tasks we had users do was to create an account, find the maintenance logs for their vehicle, diagnose a strange noise, add an entry to the maintenance log, and add a vehicle to Check Engine. We picked these tasks because they span every core piece of our app. Testing these specific tasks allowed us to test each individual screen and to get feedback on users for where they were struggling and which pieces work the best. We measured their performance based on how long it took them to complete each task and how many errors they made along the way. We're defining errors as any action that doesn't actively get them towards the goal of the task. Our goals for each task were based upon previous experience with running through our Low Fidelity prototype and some educated guesswork. We were looking for users to be able to create an account in about 30 seconds with one or fewer errors. We didn't quite reach the 30 seconds for most participants, but there weren't that many errors that were encountered by users when completing this task. For our second task, we were looking for participants to locate the vehicle maintenance logs for their vehicle. We estimated it would take 15 seconds to complete, with one or fewer errors along the way. This task gave us the most diverse time ranges of all of our tasks, with some users completing it in 9 seconds, while some took up to 30. There weren't many errors that users encountered, but it took them a while to figure out where to go to get the information that they needed. Our third task, one of the strangest pieces of our design, we asked users to diagnose a strange noise with their vehicle. We were a little more cautious with our goals. We were looking for users to spend about 40 seconds on this task with one or fewer errors. We were surprised, however, that most of our users completed this task much quicker than that, and with very few errors. Our fourth task, the users were asked to add a new entry under the maintenance log for their vehicle. We expected users to finish in about 30 seconds with one or fewer errors. We mostly hit these goals, with some outliers getting as much as 50 seconds or more. Our fifth and final task was to add a new vehicle. Another piece of our design users may not be familiar with. We are again cautious. We were looking for users to complete this task in 30 seconds with one or fewer errors. Again, we were surprised with the results, as most users finished this in under 20 seconds, with very few errors along the way. Once our participants finished all of their tasks, we asked them to take a brief survey so that we could get their impression of our application. Our survey is based on the System Usability Scale, which allows us to calculate a standardized score for how usable our app is. We calculated our System Usability score from the 5 participants that completed our survey, and we scored 78.5 out of 100. 68 is the average for applications scored with the System Usability Scale, so our application performs above average with this system. Now that we've gone over the evaluation process, Tanner will go over some of the design changes that should be made based off these results.
Based on the results from the evaluation process, we've found a few key pieces of our app that still needed a bit of work. First off, we've noticed that a few of our tasks were significantly over our targets as far as times go. Some of it has to do with us having optimistic goals, but it also implies that the workflow of our app is not as good as it could be. Adding an entry to the maintenance log was by far our worst offender time-wise. There are a few factors we've come up with as to why this is the case based on some user feedback. Firstly, we've noticed that users weren't finding the maintenance log quickly when it's located in the vehicle information page. While vehicle maintenance relates directly to the vehicle, it may make more sense to have it on its own page rather than mixed in with the vehicle information itself. We have a mock-up here that shows how this may look. Secondly, we got a lot of complaints that the buttons we included in the app were too small and easily missed. This could have contributed to the time discrepancy we noticed with adding an entry to the maintenance log, as the button could easily be missed. Through the evaluation, we also noticed some key flaws with our third task, diagnosing the vehicle. Users were much more prone to errors on this step than any other. We think that part of this is due to the fact that the way you diagnose your vehicle is a bit out of the ordinary, and that throws users off. It's also possible that users aren't given enough feedback while recording. Many users noted that they were confused about when the recording was done and how to stop it while they were recording. We've created a low fidelity prototype of what additional feedback could look like. However, to know if either of the changes we have come up with will help, we would need to do additional user testing. Check engine has come a long way since we first started. We've gone through several design iterations and user testing sessions to reach the stage we're at now. The evaluation process is important to get meaningful feedback on how our app holds up in real-world situations. Of course, more user testing could be done to further improve our design, but we've been happy with the results we've gotten thus far. This concludes our presentation for Check Engine. Thank you for watching.